Chapter 8.6 continues with our lessons on exponents. It's just more about laws on exponents. The first law that you learned was about multiplication, and we learned that if we had the same bases and we were multiplying, then we simply kept the base and we added the exponents. So x to the 6 times x to the 5th equals x to the 6 plus 5, which equals x to the 11th. We also learned law 2, which dealt with division. If we had x to the 6 divided by x to the 5th, we learned that it's x to the 6 minus 5, or x to the 1. We also learned a third law, which was the power of a power. And that's if we had a base with an exponent raised to another power, then we multiplied those powers. So x to the 6th raised to the 5th power is x to the 6 times 5, or x to the 30. We learned the definition of the zero exponent, and that is when anything other than 0 is raised to the 0 power, it equals 1. You could have a huge number, 542 raised to the 0 power equals 1. Negative 3 to the 0 power equals 1. The definition of a negative exponent is if you had x to the negative 2, it's the same thing as 1 over x squared. 5 to the negative 2 is 1 over 5 squared, or 1 over 25. And if you wanted to find the decimal for that, you would say 1 divided by 25, which would give you 0.004. Law 4 is what you're learning today, and that is the power of a product. Now we have y, which is a product, x times y, raised to the a. That means x to the a, y to the a. It's equal to that. If you had 2x raised to the 3rd power, that product would also equal 2 cubed times x cubed, and 2 cubed, of course, is 8, so it would equal 8x cubed. Now, the weird thing is that it also works backwards, okay? So if you had 12 squared, you could say that it equals 3 times 4 squared, or 3 squared times 4 squared, which might not seem like it serves a lot of purpose, but it will. In Law 1, we learned that if we have the same base in a multiplication problem, we simply add the exponents. In Law 4, we find out that if you have different bases, but the same exponent, you can multiply the bases and keep the exponent. So if you had 4 squared times 4 squared in Law 1, you have the same bases, and so you would just keep that base and add the 2 plus 2 to get the 4. In Law 4, if you had 4 squared times 4 squared, you could say that 4 times 4 equals 16, and then keep the common exponent. Both of those equal 256. Law 5 teaches us the power of a quotient, and that's if we have a little division problem, x divided by y, raised to the a, it equals the numerator to the a and the denominator to the a, or x to the a divided by y to the a. If you had numbers, you can see that we have 2 to the negative 10 divided by 12 to the negative 10. And we can simplify it by reversing, actually, Law 5 and saying that, well, that equals 2 over 12 to the negative 10. And then we can simplify 2/12 to make it 1/6. And then we can apply the definition of a negative exponent, because once we're here, we have 1 to the negative 10 over 6 to the negative 10. We can flop those. This can come up top and become positive, and this one can come to the bottom and become positive. And of course, 1 to the 10th is simply 1, so now we just have 6 to the 10th power. Okay, now both Law 4 and Law 5 relate to scientific notation as well. And you'll just see an example of the multiplication there. 3 times 10 to the 5th raised to the 2nd power is 3 squared. You have to also apply the exponent to the 3, and then 10 to the 10th, because 5 times 2, which is simply 9 times 10 to the 10th. And of course, you always want to make sure you end up with things in proper scientific notation form. Now, I know the theory is that Chapter 8 is relatively easy. We're just dealing with exponents. But now you have 5 laws and 2 definitions, and it does get complicated. So don't underestimate knowing those laws. Have a great day.